Welcome to another video series from the South Africa Swiss Bilateral Research Chair in Blockchain Technology here at the University of Johannesburg. This series is going to be on time series forecasting, where we'll be going through essentially an overview of what time series is and how to perform time series analysis and forecasting with Python. So an overview of time series. If you look on the graph on the right, you can see what we call a time series chart where we have a dependent variable, which is on the y-axis, and how it varies with respect to time, right? So essentially, time series data measures how a phenomenon varies with respect to time. And essentially in a time series data sets, the time is not considered a variable or a column. In machine learning, you would have time in a machine learning problem, the time would probably be considered as a variable, but in time series analysis is considered as inherent or the primary structure used for ordering the data. So in data science, time series problems need essentially need special pre-processing and feature generating techniques for this problem area. And so we will look at how data scientists can leverage temporal information to extract like insights from their data, from their time series data. We will look at such things as trends and seasonality and how these can be utilized to simplify the process of creating essentially like either a statistical model or a machine learning model that can be used for creating future strategy and planning, all right, using time series analysis. So like I said, time series analysis can be used for essentially trying to predict the future, and people in industry would use it as a strategy planning tool where, for example, let's assume that you work for a retail company and you want to forecast the number of sales of a particular product because you want to see whether or not you should stock this product or not. So essentially you would perform a time series forecast where you would try and determine the expected sales or sales volumes of a product in different stores in the next business quarter. So that would inform your strategy as a company. Another area could be if you were trying to determine the resale values of laptops after leasing them for a specific number of years, 2 years. And it's also quite useful in energy demand or demand forecasting, where an energy supplier is going to try and determine what the future energy load is so that they can improve efficiency and reduce waste by not generating more than is required. So those are essentially some example areas of where time series analysis can be used. As you can see, it spans a wide array of industries. Okay. So the importance of time series forecasting, like I said, is across the industry research area, right? So in the series, we will learn like important concepts for handling time series data. We shall perform analysis of time series data and build time series forecasting models. After this PowerPoint or presentation, we'll go through a Jupyter Notebook where I'll show you how to get started with time series analysis using Python. So essentially what we're trying to do is trying to extrapolate based on past trends and trying to predict the future trend. So that is one example of time series forecasting. It can be as simple as that, just extrapolating from the past trend and trying to predict either the next weekly hour trend of energy demand, or we can go to quite complex stochastic models where we're trying to model something like the short-term price movements of a stock, right? Think of something like Bitcoin or cryptocurrencies where it is highly volatile. You would need quite a complex forecasting models to be able to I guess map out future price movements. So time series forecasting models have been used to forecast things like airline capacity, future online sales and subscriptions, and sometimes also the seasonal demand for things like energy and food, right? So one of the assumptions that you should make when dealing with time series data or time series forecasting as a data scientist is that you should assume that there is no causality. It's called the no causality assumption. Assume that there's no causality that affects the measurement or the phenomena that you're busy measuring. So you should just go with the fact that this data is only as a purely a function of time, right? So your goal as a data scientist is to analyze historical values to gather insights, and then that can be used in a model to predict future events, right? For varying time horizons, right? There are various methods used to accomplish this. There are traditional classical statistical methods such as ARIMA and exponential smoothing. I shall talk about this in the Python video where I go through a Jupyter Notebook with you. However, recently, due to the wide success of machine learning solutions, right, in other areas, right, machine learning engineers and data scientists are now trying to use machine learning or come up with machine learning solutions that can produce time series forecasting solutions, right? So now I spoke about the time series data structure 2 slides ago, but I'm going to give you an example of how that looks like. So as you can see, this is essentially the price of a certain currency with respect to the dollar. And as you can see on the left-hand column is your timestamp, which is essentially the primary structure of your data series or time series data, right? And then on the right, you see price. So in this example, the price is the measured phenomena, right? So we're measuring the price of a currency with respect to the US dollar and how it changes with respect to time. In another example, it could have been the energy load, or it could have been the amount of products being sold in per day, or number of visitors coming to your website per day. So that's essentially the time series data structure. You have a timestamp and you have a variable that is being observed. Okay, so time series analysis versus forecasting. So there's an important distinction between the two, even though they're used interchangeably. So time series analysis is the aim is to try and identify the underlying structure and uncover latent traits, right, from the time series data, so that we can get to insights that can be used to make data-driven decisions or to solve business problems, right? So. And also you would use the analysis to try and understand the problem domain, right? So as a data scientist, you will essentially collect clear and actionable insights from the time series data. You will increase quality in the problem area of the measured phenomena, right? And you would then proceed to perform preliminary steps before the modeling, and this includes pre-processing and feature engineering to essentially improve the richness of your data sets, right? And essentially time series analysis is just your preliminary step before you get to time series forecasting. So then if you look at the table on the right, you will now see that you have your phenomena, right? Your close price of a certain currency, and you have the time and the known values. So you're going to analyze this data that you have, the historical prices, and then if you look at the two buttons below, 2 rows at the bottom, that was where your forecasting will come in, right? So you analyze your historical prices, and then you try and see what is the underlying insights that you can gather from doing this historical analysis. So then you get to choose the time series forecasting, right? So essentially, simply put, forecasting, you're essentially trying to create a model to predict future values. And sometimes the model can either be traditional statistical methods, ARIMA, exponential smoothing, naive method, and it can range to other complex stochastic models, or you can just use a machine learning solution. And what you're trying to do is produce future predictions of the measured phenomena by using the historical data that you have access to. Okay, so linear regression and neural networks are now being used for time series forecasting. Okay, and if you look on the right again, you can now see that is where the forecasting will come in. We've done the analysis, now it's time for us to do the forecasting. So now we will move to